Welcome to Gripo Flow. I'm going to show you how Gripo Flow helps you significantly reduce your infrastructure cloud cost. In this example, we are using Azure Kubernetes Service AKS, which is Azure fully managed Kubernetes platform. Kubernetes is a container orchestration system that automatically manages, scales, and maintains your applications in the cloud. And while today's demo focuses on AKS, Gripo Flow can automate many other cloud services as well, including VMs, VPS, GPU servers, and a wide range of additional cloud resources. This is one of the most common and impactful cost-saving strategies for modern engineering teams. And the best part is that with the Gripo Flow, setting up the automation takes only a few minutes. No complex scripting, no manual interventions. So, in this session, I will walk through exactly how to build this automation step by step, and you will see just how effortless cost optimization can become. Alright, let's get started with step 1, navigating to the workflow module. Once you are logged in, you will land on the main dashboard. This is your automation command center. From here, you can monitor all your existing workflows, create new ones, and manage every piece of automation running across your business and cloud environments. Now, since we are creating cost-saving workflow for AKS, we are going to head straight to the workflow module. This is where all the magic happens. It's where you build, design, and orchestrate your automation logic. To begin, just follow these 2 quick actions. First, click on Workflow on the left navigation panel. Then click on Create Workflow. You will see here the workflow which we have already created. Now, if you want to make the new workflow, we will click on Create Workflow. As soon as you do this, Gripo Flow opens up a workflow setup screen. This is where we will start building our AKS cost-saving automation. So first, I am going to create a workflow just like a typical on-demand cluster. Start and stop workflow, the kind you would normally run manually. This will help you to understand the basic process, and then I will show you the real power of Gripo Flow, how you can schedule your Azure Kubernetes cluster to start and stop automatically at the exact time you want. No manual efforts, no reminders, fully automated. So first, I will demonstrate how to stop the cluster using a basic workflow method, just to show you the manual version. And since our Azure cluster is currently running, so I can show you right here before we will proceed. So it's in running state. It's in running state. So now back to the workflow. Now the name, start by giving your workflow a clear, meaningful name like stop. As we have a cluster, running cluster already, so we have to stop it manually. So that's why I have given it the stop name. Then add a short description that explains exactly what this automation is designed to do this. Next, choose the workflow type. In our case, we will select on demand, which means this workflow can be triggered whenever needed. You can also configure retry settings. In our case, we will set it on 12. And tags. If you want to organize your workflow by team, category, or environment, these are optional but very helpful for keeping things structured. So in our case, we'll type an Azure. We will click add, and once everything looks good, simply click on next to proceed. Next, we have an optional step, adding variables. Variables are incredibly useful because they make your workflow flexible and reusable, especially if you are managing multiple AKS clusters across different environments. For example, you might create variables such as cluster underscore name or resource underscore group. These allow you to run the same workflow on different clusters without rebuilding anything. But if you don't need variables at the moment, you can simply skip this step. So we are going to skip this step, and we'll just hit on save and continue. Now your workflow has been successfully created. Now that the workflow is set up by the name stop, now let's add the activity to stop the cluster. In Gripo Flow, activities are basic automation tasks which can be used to build the workflow. Now we will click on the plus sign inside the workflow canvas, and as soon as you will click it, a new window will pop up. So in this window, you will see two options, apps and plugins. For this demo, we are going to start by selecting apps, which is already selected. And from the list, we will select the Azure Managed Kubernetes activity. Here it is. We will click it, and we have to choose a stop cluster action from the list. So stop cluster. Since our cluster is already in running state, so we will use the activity stop for the cluster. Next, fill in the required details, your connection reference, the resource group, and the cluster name. Once everything is filled out, click submit. Now that the stop cluster workflow is ready, and we will add another activity to connect it with Slack and send the notification that the cluster is stopped. Gripo Flow has built-in support to integrate with Slack, which means you can use Slack activity in any of the Gripo Flow workflows. So just click on the plus button in front of the Cloud Managed Kubernetes activity. Select Slack from the list. Choose Slack message. Type your message, for example, your cluster is stopped. Provide the Slack connection reference and select the appropriate Slack channel. This ensures that your team receives a confirmation whenever the cluster is shut down. Once the Slack notification activity is added, and then click submit. This ensures that your team receives a confirmation whenever the cluster is shut down. Once the Slack notification activity is added, click on save. And before hitting run, check that the cluster is on running state. So let's go back to the Gripo page and see whether our cluster is running. Yes, it's running. So as you can see, the cluster is in running state. At Gripo, we have also a separate cloud platform to manage Kubernetes called Gripo. And you can read about the details of Gripo on our website. Now let's go back to the Gripo Flow and now hit on the run button. The workflow is running successfully. So let's see first that the message has appeared or not on Slack. See, your cluster is stopped. And now let's go back to the Gripo page and let's see the cluster is stopped or still in working. See, it's stopped working. So now we move into filling out the workflow details for starting the cluster. Again, we will create a new workflow for starting the cluster. Click on the create button. Again, we will choose the name by the name of start. As we have just stopped our already running cluster by our on-demand basic workflow, so now we will start the cluster with the same basic workflow. Then a short description, workflow type, on-demand, retry, tags, and click on the next to proceed. Again, next is the add variables. We'll skip this step and save and continue. Now your workflow has been successfully created. Now that our workflow is set up by the name of start, now let's continue to add activity for starting the cluster. Again, we'll repeat the same steps for starting it. First, we'll click on the plus sign. Then we'll choose the Azure Managed Kubernetes activity. Then choose the start cluster. Since our cluster is already stopped, so we will first create an on-demand workflow again to start it. Now fill the required fields, connection reference, resource group, and the cluster name. Once everything is filled out, click on submit. Now that the start cluster activity is ready, let's add the Slack activity like we did in the previous workflow. Now go to the Cloud Managed Kubernetes activity and click on the plus button. Select Slack from the activity list. Choose Slack message. Type your message, for example, your cluster is started. Connection reference and Slack channel. Once everything is done, click on submit. Now that our workflow is ready, click on save. Again, we'll check on the Gripo interface that the cluster is still stopped. Let's go back to the Gripo Resources page. We will refresh it. Our cluster is stopped. So let's go back on the workflow page. And now we will hit on the run button. For confirmation, we will go back to the Gripo portal to confirm that the cluster is started again. Starting running, and again we'll see on the Slack message, your cluster is started. This was the manual work where we first stopped it manually. Then after we again started it manually with the basic workflow method. And we added the Slack message to inform the notification updated that we have started or stopped the cluster. So after the manual setup, we can automate this starting and stopping the cluster on schedule according to our need by choosing the cron job, where you don't have to do it manually. Gripo Flow will take care of it. And this is how we make it. Using the parallel path, now we will create the setup only in one go. So your cluster will start and stop according to your need. Now we will create a separate workflow. Let's move into the most important part. Automation, automating the actual cost saving logic. This is where we will build the intelligence that dramatically reduce your Azure bill by starting and stopping your AKS clusters automatically. Think about this scenario for a moment. Imagine you are running a large commercial or corporate company. One day, you suddenly notice that your cloud billing has increased dramatically, far beyond what you expected. You start investigating and realize something surprising. Your cloud provider costs are rising even through your teams only use the cluster during working hours, but the cluster remains running 24/7, even at night, on weekends, and during non-working hours. This means you are paying huge amount of money for compute you are not even using. Naturally, you start asking yourself, why we are being billed so much when we are not using the cloud all the time? What can we do to control and reduce these unnecessary costs? And that's where the real solution comes in. The magic Gripo Flow. With Gripo Flow, you finally get a smart automated way to reduce your cloud expenses instantly. Here's how it helps. It allows you to schedule your clusters. It automatically stops your cloud resources after office hours. It automatically starts them again in the morning. It ensures you never pay for idle or unused compute. It works with Azure, Kubernetes clusters, and many other cloud services. It means your cloud infrastructure is only running when you actually need it and completely shut down when you don't. So now let's get started. Click on the right side button to create workflow again. Fill in the basic information and a short description. Next, the workflow type, on demand, retry limits, and tags. Once everything looks good, simply click on next to proceed. We will skip this step again, save and continue. Now, the workflow has been successfully created. Now, as you can see, our basic workflow is ready. Now, we will create the parallel path. And before jumping to the automation workflow, I will first explain that what a parallel path is. Parallel path is a workflow feature that allows you to run multiple branches of automation simultaneously within a single workflow. Each branch can execute a separate set of actions independently, such as starting a cluster in one branch and stopping a cluster in another, allowing tasks to be scheduled or triggered at the same time without interfering with each other. Imagine how many automation scenarios you can deal with this powerful feature of Gripo Flow, adding parallel path to the workflow. Next, on the canvas, click on the plus button. We are going to add a parallel path. This allows us to run the two scheduled automations under the same workflow. One branch for starting the cluster and another for stopping it. Here's how we will do it. Now let's continue building the workflow. Click on the plus sign inside the workflow canvas. In our case, we are going to select the core now. Now, from the options, choose the parallel path here. This is what allows us to build the multiple scheduled branches inside the same workflow. Click Add Branch to create new path. Give the branch a name, for example, Stop Cluster. We will enable cron job. And next, we will set the schedule time according to the UTC time. So, right now, the UTC time is 12 past 5. We will schedule this to stop at 12 past 15. First minutes and then hours. Once everything look good, click on the add. Here we will not click on submit, as in the same workflow we have to add another branch too. Now let's create the second branch. This will handle the start cluster schedule. In the same way, just add the name start cluster, enable cron expression and give the schedule time when it has to start actually the cluster, and it will start automatically. So I will give the time UTC time 12 past 20. Once everything looks good, click on add, and now we will click on submit. And now you can see we have two branches in the workflow, one that automatically stops the cluster and the other that automatically starts the cluster. So this logic is mainly for that which automatically starts the cluster in the morning and that automatically stops the cluster in the evening according to the schedule we set. Now you will see both the start cluster and stop cluster automations added as a parallel path branches, clearly visible and fully configured within the workflow. Now let's assign the stop action to branch 1. For this, click on the plus button. We have to do the same procedure we have done before. Now, from the list, select the Azure Managed Kubernetes activity. From here, choose the stop cluster. Next, fill in the required details, your connection reference, resource group, and the cluster name, and click submit. Next, we will assign the start action to branch 2. Click on plus sign. The same way, we will choose the Azure Managed Kubernetes activity and the start cluster. Now, click on the connection reference, choose the resource group and the cluster name, and click submit. Once everything is set, and that's it. Now your cluster will automatically shut down after office hours or you scheduled, ensuring you to avoid unnecessary compute cost and save money on your Azure bill. So now let's make you sure that your team stays informed by adding a Slack notification. We will now click on the plus button, and now from here we'll choose the Slack activity. Choose the message, same, the connection reference, and finally the channel. Click submit. The Slack activity has been added here for the stop action. Now for the start action, we'll click again on the plus button, click Slack, choose Slack message, start. Select connection reference and finally the channel. Click on submit. Now once everything is done, we'll save the workflow and we will hit on the run button. Now it is scheduled and it will run automatically. It will stop the cluster and then at the specific time which we have mentioned, and then it will again start the cluster according to the time which we have selected. So let's see, we are here. After 2 minutes, it will stop the cluster, and then after that stopping the cluster, it will start again after that 5 minutes. So let's see. We didn't get any message yet. Let's go back to the Gripo Resources and see what is the situation of our cluster. It's running. So first, back on the workflow page, it will first stop the cluster 12 past 15 and then it will again start the cluster at 12 past 20. So let's see. We'll get the message and also what will happen. See, we get the message, your cluster is stopped and our first workflow is succeeded. Let's go back and see on the Gripo Resources that our cluster is stopped. Yes, see, it stopped the cluster automatically. I didn't do anything. And now it will start again at 12 past 20. So let's wait for that as well. See, it's 12 past 20 and we have received the message that your cluster is started. It means it start working. Wow, it start running. So now you see that the cluster has been stopped and start automatically as we scheduled. So think about this. How much money could be saved when developers don't have to manually shut down the clusters? The clusters automatically shut down after office hours. It starts automatically during morning office hours. All you need to do is set up the schedule once and it's done. In this way, companies can save thousands of dollars in cost just by automating clusters, start and stop times. So finally, wrap up that you can perform thousands of other automations with Gripo Flow. Tasks that used to take DevOps and SecOps teams hours to complete manually can now be done in just few clicks, saving both time and cost. Thanks for watching us. Thanks for watching Gripo.